graph transformations. In this video we'll have a look at stretching graphs parallel to the x-axis and stretching graphs parallel to the y-axis. Let's start with this U-shaped curve. We're going to apply a ×3 stretch parallel to the x-axis. The graph before any transformation is applied looks like this. I've got 2 points A and B on this curve, and we'll have a look at what happens to these 2 points. If you stretch in the x direction, we'll find that the y coordinates are unaffected, but the x coordinates are multiplied by this stretch factor. So if we have -4 and that -1, multiplying them both by 3 will give you -12 and -3. So after the stretch, points A and B are now here, A dash, B dash, -12 and -3. And as you can see, the y coordinates are still 2, they haven't changed. To get the new equation of the curve, you need to replace x with x divided by the stretch factor, which in this case the stretch factor is 3, so I need to replace x in this equation with x divided by 3. Okay, there are 2 instances of x in the equation here, so the new equation will become y is equal to x over 3, that's replacing the x there with this, squared plus 5 times x over 3 plus 6. Okay, starting with the same curve again, this time we're going to apply a stretch of ×1/3 parallel to the x-axis. Looking at the graph, this is the graph before any transformation has been applied. So if we're stretching in the x direction, the x coordinates will be multiplied by the stretch factor, which is 1/3. So this becomes -4 over 3, and this one will become -1/3. The y coordinates are 2 here, they both remain unchanged. And this is the graph after the stretch has been applied, and you can see the x coordinates have both changed, the y coordinates are unaffected. But what happens to the actual equation of the curve after the 1/3 stretch parallel to the x-axis? Well, following this principle again, we're going to replace x here with x divided by whatever the stretch factor is, which is 1/3 here. So if you do this, x divided by 1/3, this simplifies to 3x. So you're actually replacing x with 3x. So the new equation becomes y is equal to, and I should put brackets around here wherever I use this, so 3x, that's replacing the x here with that 3x, so squared plus 5 times 3x, that's replacing the x there, plus 6. So this is the new equation after the stretch parallel to the x-axis of ×1/3. A common mistake is to think that because x has become 3x, it looks as though it's a ×3 stretch in the x direction, but it's not. That's deceiving. If you find that x has been multiplied by something like this, then be careful, because the stretch factor was probably some fraction. Starting with the same curve again, but this time we're going to apply a ×2 stretch parallel to the y-axis. Let's have a look at the graphs. So before the transformation we had this graph, and this time I'm doing a stretch of ×2 in the y direction parallel to the y-axis, what we'll find is because we're stretching in the y direction, the x coordinates, so that's the -4 and the -1, do not change, but the y coordinates this time will be multiplied by the stretch factor. So because the stretch factor is 2, that becomes 4, and this one becomes 4. And this is the graph after the stretch in the y direction of times 2 has been applied. And as you can see, the y coordinates have changed, but the x coordinates are still the same. To stretch a graph in the y direction, all you do to the equation is you multiply the original equation by your stretch factor. So it's 2 times x squared plus 5x plus 6. It's simple. In the y direction, things are always easy. If the stretch in the y direction was not times 2, let's say if it was times a half, we'll use a fraction this time. So we're doing a times a half stretch, and all we're going to do is multiply the original equation there by a half. It's that easy. Okay, let's have a look at function notation and stretching graphs. In the first one here, I've replaced the x there with x over 3. That's showing a times 3 stretch parallel to the x-axis. In the second one here, I've replaced the x with 3x. This is a times 1/3 stretch parallel to the x-axis. In this one here, I've multiplied the original function there by 2. This is a stretch of times 2 parallel to the y-axis.